many people have joined us physically, but we have a few people that have joined us in our virtual meeting. We are basically here for a public discussion forum arranged by the Kitwe branch. So today we're going to have 3 presentations. The first one will be by Engineer Dr. Michael Kensefu, and it will be on engineers' role in climate adaptability and integration of resilience measures in managing projects. Our second presentation will be by Engineer Kombeka Kendela, and that will be sulfuric production technologies and its significance. And finally, we have a presenter who is going to be presenting virtually, that's craftsperson Pius Mwanda, and he'll be presenting on engineering skills as a frontier to economic transformation and lifelong empowerment. After that, we're going to have some questions and answers of the presentations, and we'll have our closing remarks by Engineer Christian Banda, that's our EIZ Kitwe branch chairperson. Unfortunately, our chairperson for the branch, Engineer John Siam, has traveled and was not able to join us today, but we do hope that he joined us virtually as well. So we just want to encourage everyone to feel free to participate, to listen attentively to the presentation, and to just interact also with everyone else after we end our forum. And once again, we thank you for joining us.
Thank you very much. I think we can give a round of applause. You know, these public forum discussions are very important for us as engineering professionals, maybe just to give emphasis before the best presenter is here. You know, most of the time we spend a lot of time at work, and we may not be in touch with what's happening elsewhere. We find that maybe processing what's happening in production and what you're doing and aware of what's happening elsewhere. And also, it might be an opportunity to try and understand on the improvements in terms of knowledge that you might be missing. This is the right forum, and we encourage each and every one of us to challenge ourselves and not to be static, but to push our limits so that even as we are practicing, whatever solutions we are bringing to the table, these are things that are working, and we can be seen to be developing. Let's not just be engineers that are bringing to life ideas that were done in the 1960s and we're still doing the same things. But let us endeavor to be different and bring new ideas. Even as we pass on the baton to people that are coming after us, they can find that the disciplines that we have and the profession of engineering is something to look up to, and it's bringing meaningful change, which has something that is reflecting on what economy needs and what is relevant to our times. Dr. Engineer Sefu, can you pick it up?
Good evening once more. All the senior engineers here. Also, like the protocols we present. It's quite a sad day for engineers today. We lost one of our senior engineers, fellow engineer Leah Banda. So happy that she was my investment and also my student. She was doing a master's and also survived my attention. So, on behalf of the EIZ president, I ask you to stand and to accord a minute of silence. Of engineer Uganda arresting this. I'm the presenter. Those are my names. Most of you know me or may know me. council member, chairperson of the Technical Committee. And I'm based in Ndola. I'm the Northern Regional Manager for Zambia Insurance Agency. You know, my family is in Zambia. What a very interesting topic. This is what really is now affecting us, climate change. Now, it's in two parts. Because of time, today we only do one part where I introduce it and we speak a bit about the tools and techniques. But next time, then we're looking at the application of the tools for adaptability. And so we will look at what climate change is. I think everyone is talking about it, and we are witnessing. We've seen it. So sad that Madagascar has just been hit with a fourth cyclone as of this morning. So you can see the frequency of the weather patterns out there has changed. And that goes with the weather, a little changes in the oceans, land, surface, ice sheets, occurring over time. Now, when you look at the changes, this is, we look at in terms of the changes, the properties of the climate system, that is for several decades or longer, usually at least 30 years. Now, where you're used to this pattern, then all of a sudden just changes, then begins to affect solar. And that affects us engineers. So we look at now how do we get into adapt in that things have changed, because things are no longer the same. Now, once you adapt, now how do you bring in the resilience measures? So I walk you through in that. You see, because of this frequency and severity of severe weather, including the flooding, high temperatures, and post-drought, it poses a significant climate change risk to infrastructure. What it does. Now, if you look at that, all these are which. How come they just recently constructed this street, this road, this energy infrastructure, and they just collapse the following day? This is what is happening. Now, it's because of the climate change risk, which we need to clear. Because a layman in the street, you just point at it, no, it was in nearby what was in this project. But you're forgetting this one. Now, the issue about this phenomenon of the weather changes is that the flooding and the heat waves directly impairs the performance and longevity of buildings and infrastructure. You see, when you're designing the specs, during the designing and so on, we make sure that we're following certain standards, certain codes, and so on. But because of this severe, it affects and gets into what we have designed. Of course, we should not run away from design defects, which can. But I'm talking about this natural calamities can affect good vertical down. Furthermore, it alters the nature and magnitude of environmental associated. As I said, when we are doing a designing and we're doing the modeling and simulation, we take into consideration certain parameters. For example, you saw a few weeks ago, how the billboards were flying like a kite because of the wind. So I think if you go back seconds from the disaster, did the engineer do the work? Probably yes, they designed it very well. But did they take into consideration that the weather speed now has changed? I think that's a topic for today. And you see, this has affected critical infrastructure in all sectors. Agriculture has been badly hit. I think the agriculture engineers are really suffering in this aspect. They will install a center pivot today, the following day it's flying, they'll look at the greenhouses, the pipes and so on. They are being badly affected. In my mind. I was wanting to be still the lecture, so I lecture. trying to say. If you look at, because my voice is loud, I can do that. Yeah. So now, if you look at the road infrastructure, what happens is that these high temperatures, even the severe storms and flooding, they affect the reliability and the capacity of transportation systems. The roads. It really affects it, such that it alters the moisture balance and it influences the pavement. Put up all the factors. Because if you look at this pavement, should last at least 15 to 20 years. It affects the pavement deterioration. It accelerates it. The rural infrastructure is not spared as well, because in terms of what its frequency and the extreme weather condition caused by the CH, the climate change, it impacts the ability to run rail safely and on time. Of course, we are not using much of the rail systems in Zambia compared to other countries where they're using it. They've felt this impact. Where a lot of sum of money is spent on a project like this, barely before even do amortization of the loan and the payback, the project is gone. Of course, the blame comes back to the engineer. Energy infrastructure, not spared as well. Because we find that climate change triggers both electricity demand. This is the weather just suddenly changes. In October, you don't need, you find it's very cold. August is very cold. September is cold. Why you don't need the heat? You end up not switching on the heater, the geyser, and so on. So it increases the demand for electricity. And other energy resources. It also affects the amount of water available. If we had El Nino, because according to the certain type of climate, we face El Nino every after 4 years. The El Nino is either too much rainfall or too less rainfall. We have this problem of the load shedding and so on. That could be attributed to climate change. Even when there's too much of rainfall, the team will tell you that it might affect their works as well. So now we need to look at, we have got this situation. What do we do? And this is what now getting to adaptation. We adapt to the situation. Now, for this, all of us here as engineering professionals, we must internally determine the needs and the capacities to tackle the climate change impacts. Adaptation for now, and plan for sustainable adaptation for the realistic future scenario. Now, what is adaptation? We are saying adjustments in natural or human systems in response to the actual or expected climate change stimuli. So these things which we are encountering, now we adapt. But for us engineers, is that we don't just adapt on at the window of the month. Now we go back to the other series, all the designs we have done, so that you bring that now into what you're designing. We change the scope so that it now suits the parameters which we're encountering. That's why I told you about the tools and techniques, which is the second part of the presentation, which will go into details and bring that short. Now, how do we do this? One, this should be done through systems perspective, technical knowledge sharing, and also and the I think there is a call now for innovation of engineers and being creative, where we don't keep on looking at the T-square. Now we see what can work. If we have been using 6-inch bricks, and 6-inch bricks are seeing that the buildings are collapsing, what can work now? If the ratio of cement to sand is this, and so to it, what can work now? That is where the innovation component comes in. Now, this can be done through structural options or non-structure. The structural one We're talking about modification to the design or specification of infrastructure. So we want to construct this chicken run, for instance. Now, we don't do it the way I've been doing it from 1982, 1990, because now things have changed. So we modify it. And that's why the community is looking for, Engineer Mongo, how do I go about it now? Because last time I built, I did construct a chicken run at my farm and it collapsed within 4 days. Now, how do I do it in a different manner now so that it can stand the test of time? Sustainability comes in, and also I get the value for my money. This is where we get into modification and designing of the specification in place. And one is we look at the detailed design drawings, and then we look at the final prototype of it. We do a lot of modeling and simulation. Can it work? We have got these parameters, and we say we've got this prototype, and then we subject it to various stimulation. If at all we had that, if a speed, for example, it's a billboard, and the speed which is moving at 10 kilometers per hour, how can it behave? That is now behind the closed doors. Do that. Now, what if we subject it to 200 kilometers per hour? Then it says it's going to fly like a kite. So what can we do to ensure it does not fly? And that is where now innovations comes from, which you, the professional engineer, can do. Yes, you can do. If you remember the thermodynamics, the fluid mechanics, all that mathematics you are doing from first year to fifth year, it's now time to apply it. Of course, there are certain tools and techniques which can assist you to do that. That's our second component which we will do. So you can run around that until you come up with a fine, improved, and modified prototype which you can put to test. An example of structure can be changing the position of the road surface so that it won't form. Because we have seen everyone is doing it, everyone is doing this, but why don't we change the composition now so that it does not form during extreme weathers? And this is a good example where you look at the chemical paving surface to reduce runoff during heavy rain. So you see, you have such, but even if there is heavy rain, the water will collect down, then the runoff, and it will find itself in the ground. That cleaned it for you. It's like a sieve. There are some of the designs which engineers we can bring on board. We can suggest this. I know it has got the cost implication component, but that's why we are innovative and creative to convince the financiers of the projects that why don't you try this? Because you don't want to do the work and which is washed away the following day. One which I've been speaking more, emphasize more, is on the modeling and simulation. I think engineers should spend more time at designing and planning, where we keep on trying. See, when they're training pilots, they won't be in a simulator most of the time, and they'll be subjected to different parameters until the pilot knows how to handle during landing, if there's high storm, no storm, and so on, things like that. And that's what we need to do more. We need to now get dealing with the software which can work. And yes, it has worked in most developed countries. They are using this. We get into the softwares, do the modeling and the simulation. We try the specifications, we get the same specs which are important. Oh, these are the specs we're going to use. Let's subject them to the modeling and simulation so that we can adapt to the new environment. The non-structural options, this involves more of the monitoring of emergency and response programs, which we can design the monitoring aspect. Of course, it should be cost effective. If you have done the road between Mikambo and maybe Mufulira, for instance, you design a mechanism of how you can monitor how is it responding to certain stimuli. That could be one of the non-structure. Another one is a training. There is a lot of training going on. Most of them these are online. But of course, we are busy in the plan sometimes, and maybe it misses us. Let us try to get to those trainings going on, most especially on the climate change. There are a number of training going on, and what this can help us really to understand the environment. Because if you want to grow your paprika now, and you want to go blindly, getting the statistics from pattern and so on, then people laugh at you. They're saying learning has not taken place. So it's high time now we left our cocoon and then we go flat out and trying to get the best practice happening on infrastructure. And learning can be one of the good parts. Another one structure is the development of strategic and corporate climate risk assessment framework, where we develop the framework where you can easily identify the risks. During my PhD, one of the things I did was to develop a risk management model, which is very simple, which we can do everyone, colleagues, that we develop a model, a framework, which can easily identify the risks and then look at the probability of that risk occurring and also the impact as well and the mitigation measures. But this will enable us to fight this animal, the climate change, which has hit most of our projects. Of course, we need the financial component aspect as well. And then let us embrace the insurance on these projects. For some of them, the force majeure acts of God, we can easily bring in the insurance. Because we can do as much as we can do, probably reinforce in terms of our specifications, modify the prototype, but we are hit. Where we hit with this uncertainty we shouldn't expect. And that is where probably the insurance can come through. Yeah, now, there are tools and techniques for adaptation. You see, I said, I'll just mention, but my second lecture, second paper which I'll present, I will do now, we'll go into the software and see how they operate these tools. Planning frameworks. Tools where to look at even the vulnerability of the area where you want to develop your project. These are very good tools which we need to get familiar with because they are very interactive. It looks at the institution's capacity, even the manpower you've got, and they have the technical know-how in that area, and can they integrate climate change, the technical procedures and financial aspects, the resources, laws, the legal framework surrounding your project. You can't just bring up anything, just be guided by the legal framework and the policies. So these are some of the tools which you can look at. The other one is the infrastructure project and policy appraisals. It's one of the framework which can be used when you want to get into the adaptation, because it talks about the visibility aspect of your project before you start the planning and the execution. It gives very good guidance. It's a very brilliant tool which we can use to appraise and give a go ahead to our sponsors to do that project. Another one is the regulatory and economic standards, where we look at the heuristic principle, public participation principle, equity principle, environmental principle. We integrate all these principles, and definitely we can come up with the best product which can resist or get into resilience when it comes to climate change. Now, so we have gone into the adaptation, and we have this at that point. Now we understand that climate change can hit us, and we have brought in these tools and adjusted. Now, how do we get into resilience? That even as much pressure comes or disturbance, even though it's so big that it can be, and there's too much flooding, there's too much wind moving it, but it can still stand. That is the resilience. Now, what is this? They are being bounced back when faced with stress or pressure. So at this time now, this agrees with me when I was speaking about modifying the scope, modifying the specs, so that even if it's hit, and that can be achieved Because remember, we had tested this prototype. We are on the laptop, use the software, and we tested it with various types of parameters. So even now, when you go on the project and we install it, it's able to start. Then we can raise our hands, says it's able to encounter resilience. So I think I was talking about this. Now, we're saying is engineering profession. We need to have access to high quality information. So in short, let us bring in a bit of some R&D, some research and development. Colleagues, we are very brilliant. We graduated many years ago, but things are changing. So we need to trigger a bit of some research now. Let us see what is happening now. We need to trigger that. Unfortunately, we have to read. If we don't read, the young graduates will come and read for us. Then we'll be in the boardroom and then we'll forward certain questions. We need to bring in something of high quality information and consistent data. Also, the capacity to use the information for designing and planning of the work. So it's one thing of you have read a lot and you have got this information. Now, how do you bring it in and integrate it into your designing? And also, if it can be bought by the financiers. Because most of the time you find that you have put so much brilliant mind, but the project developers or the sponsors, they're looking at the cost aspect of it. So it's how we sell them. How we sell the idea says we will go back, if you do it in a traditional manner, we don't add this component, definitely we're going to lose out. It's how we sell, how management buying into what we are doing. Now, there are tools in resilience as well, which we'll do in our second lecture, not now, is the scenario analysis. I've used this much more on risk assessment. The scenario analysis. You look at what happens if there's high temperature, what if there's low temperature? What if there's high wind, low wind, or it remains constant at a certain point? So these are the tools which can be used now. The decision-making diagram, lucid charts, decision metrics, mindfulness, Pareto analysis, Bayesian paradigm, force field analysis, mantra. So there are these tools which can be used in the resilience. Of course, the access to information should be complemented with the development of the technical capacity as on this one. Now, what is the way forward? First is that colleagues, we are the center for change. I told you, a chicken run which has fallen down, the issue just goes to Engineer Mwango. He's the one who was at site. So we are the center for change. But at the same time, ourselves, we must first learn to change. Then, as I was talking about, bring some R&D now. Let us begin to research more. We have proved we are very intelligent, we passed, graduated, but let us prove to read more, to research more on our works, see what is happening now. So we can seize more opportunities and be predators enough to pick up the time. Now, secondly, is that not only we should continue to innovate or to recognize best practice from around the globe and retain their status as trusted experts, but we must also move away from being job takers. Now, being job takers is where I've just joined Mopani, and then I get into my PP and start doing the work. Why don't you first analyze? Because you find, look, my friend was there, Jinamang was there, he left the specs and so on. So just go straight and take up that job. I think we need to interrogate most of it. We end up being in trouble, where if somebody starts a job and you don't know what the specs are there, then you just continue that. Suppose they did not integrate certain parameters to resist, so you become the blame. We need to move away from that mistake. Then we should also try to better communication, which is very important. And no, we should be the part of the board. Actually, in the decision making, that we should strive for leadership. And that means we reduce the apathy for elections at TIZ, for attending this. We need to remove that apathy because we are both candidates. And only if we are colleagues, we reach at a point where you're part and parcel of people making decisions, then we can influence what I'm talking about. But if you are just at the far corner near the kitchen or near a warehouse, it's very difficult, colleagues, to make some certain decisions, to influence certain decisions, we need to strive for that corporate leadership. We have to be corporate cowboys, cowgirls, corporate cowboys. I'm using that term. And then, of course, we must be trusted advisors. Now, this one is very interesting. Saying we must be trusted advisors means when we recommend, at least the probability of failure must be very, very, very low. We have recommended. Says the engineer Zulu has recommended this, and you have implemented this. The probability of failure must be very low, which means we should have done our homework. We should have done our homework and put this in consideration. Remember, we're fighting it. We're fighting climate change. If we do it the same way, then we will lose it up. Now, finally, it's I'm talking about integrated designs on infrastructure projects, where we bring everything. You look at the architects, they do such nice building like this. But you see, if there is no integrated components from bring the structural engineers, the chemical engineers, and everyone to come together so they can assist the architects what they have designed. This is subject to failure. Look at the aesthetic of the. Actually, I'm the ETC chairperson. So I was the one who was investigating the flower bridge at Unilas Musaka. It looks so nice, so aesthetic, but it does not make the design. It's a danger. So something can look so beautiful like this, but if you don't bring in the integrated design infrastructure, meaning that we bring all our skills together with the architects and everything, then we can fight the climate change. Thank you so much.
Thank you very much, Dr. Wonderful. Fellow engineering professionals, I think just a slight modification in the program. We're supposed to have a question and answer session at the end, but then I feel it will be quite constructive if we can engage the question and answer session after each speaker has presented, so that we don't forget our questions or any queries that we had. Before we can jump into that, I would just like to recognize the presence of our Vice President, Membership and CPD, Engineer Monica. So if there are any questions regarding the presentation that we just had from Dr. Zero, please, questions are welcome. Yes, please. Thank you very much
the observation is, you see, the problem that we have, when I looked at your definition of climate change, you used the word statistical. Meaning, when we look at that, we're looking at something that may be changing gradually. But you see, sometimes we want to pretend as if everything is static, which is not the truth. So meaning, we have to be reactive. Like we look at, don't pretend like the earth doesn't change, because it does. Now, as we are doing our design, are we taking into consideration the changes that might come? And then in your presentation, you're talking about resilience. From my standpoint, I think if you design something that will withstand the weather today, chances are that it might fail. You might have to take into consideration what might come in the future. What I have in mind, for example, we may have to embrace things like the study of deep learning, where you use what has happened in the past, maybe 30 years, then we extrapolate to what might happen in the next 50 years. Then we put that into consideration. Are you looking at that kind of stuff for us to put that into consideration so that whatever we design, it will really stand the test of time?
Any other question?
very much. I'm Engineer Sarah Sugeme. The presentation was excellent and very educative. I just have two questions. In the designs of any structure, road, or building, we follow the standards, the Euro codes, the BS. Now, when we start analyzing the structures, the roads, are we going to change or input our findings so that the standards that we use for design incorporate those changes, the climate change? And secondly, the money. Yes, we need to involve our stakeholders, because most of the designs that we come up, they have to be economic. We might specify a number of skills so that the structure will stand a certain amount of cost of climate change. But the issue borders on money. Recently, as the engineering fraternity, we've been boxed here there about the cost of projects. I think as we do our research, I think we need to involve the stakeholders so that they really know the true cost of these projects. Thank you.
The senior engineer talking about the past, looking at historical data to be incorporated. I agree with you 100%. We really need to integrate the historical data, because you can check what has happened in the past 20 years and what can happen. You know, the econometrics, what they do when they're coming up with in the contracts, when trying to sign the contracts and look at the exchange rates, which are going to have, it's a 5 years contract. You quickly look at what has been the change of the rates for the past 5 years. And then you use those econometrics to come up with this. The same thing senior engineer can do in our case. I know there are standards which we are using, but sir, I'm just saying that those standards, things are changing now. The good part is that we can easily see how best we can modify those standards because of what's happening now. Now the cost implications comes in the financial aspect. That's why it says if we're able to be part of decision makers, we can easily say it in the volume using a cost benefit analysis. It says, okay, the cost is this, but the benefits are here. If we do a traditional way, the building will last for 3 years and 2 years. But if we had to say extra $10, it will stand this much. I mean, it's how much now where we bring in the professional reason with us and we say, sir, this cannot work because of the pattern of weather we are facing now. Thank you.
Thank you very much. Those responses have cleared the questions we had. I'll invite the next speaker, Engineer.
Good evening. I think also just speak about my affordable enough, I believe. So my name is Kombeka Kengera. I'm a chemical engineer by profession. Currently, I'm working for KCM Smelter Co. I've been working for KCM for 14 years now. I'm working as a plant metallurgist and acid plant. So today, basically, I just want us to appreciate the acid, the sulfuric acid technologies and the significance. We're able to just one of the critical things is that if a lecturer has been speaking and then he use not a skill that come on to speak, it becomes a bit of a problem. But I'm sure I'll write on the grace that he has left. So like I said, my name is Engineer Kombeka Kenyera. So basically today we just want to appreciate and talk about the sulfuric acid technologies and the significance. The lecture contains the production significance of the sulfuric acid, and we try to look at the global production and the market trend, and appreciate, of course, the sulfuric acid process theory, the types of acid plants that we have available, the available technologies, and then the current situation in Zambia, and then look at the way forward. How do we move from where we are now, and then make a conclusion. So straight away we'll go into the introduction. Basically, we're trying to define what a sulfuric acid is. Basically, this is it has got several names. It has got what we call hydrogen sulfate rather, or what vitro. And this is basically a strong mineral acid that is composed of sulfur, oxygen, hydrogen, and that is the chemical formula for sulfuric acid. Then we look at the physical and the chemical properties. So the physical properties, we are looking at the boiling point being around 300, the freezing point 10.3, and density and the viscosity. More critically, we look also at the chemical reactions. This sulfuric acid, when it comes in contact with water, what happens? It's very miscible with water and is able to actually produce large heat of solution. Then this concentrated acid, when you react it with non-metals, it's able to produce those other elements that you're able to see from there. It's also able to react with, I think we will appreciate, most of us who've done the chemistry, we know about the electrochemical series. So any elements that are above hydrogen is able to react and produce the sulfates. And then also those below it is able to produce hydrogen. And of course, it's not able to react with the non-metals. A bit of some history. The sulfuric acid basically first was produced by distillation, that is in the 8th century. And then, of course, a gentleman called Gerhard went on to look at the properties of sulfuric acid. And another gentleman called Andreas was now trying to look at the different methods that can be used to produce this important chemical. Of course, further on, we saw the introduction of the chamber method. And then we have another gentleman called Phillips who went on to build on how they can enhance the production of sulfuric acid by coming up with a process called contact process. Now, to ensure that we produce this chemical in large quantities, we needed to look at increasing the rate of production. So other gentlemen went into looking at what catalysts can be used so that we can improve this production. So they came up with the vanadium hydroxide, which is the catalyst that is used for production of sulfuric acid. So, what is the significance of this chemical? This is a very important chemical in the sense that it has various applications in the fertilizer industry, in the mining industry, the chemical industry. There are so many, but you discover that out of all these uses, fertilizer takes the bigger portion. Without sulfuric acid, we are not able to produce fertilizer. Without fertilizer, we can't talk about bumper harvest. So this is very critical. In the mining, in the case of Zambia, we see this material being used for leaching so that we produce a copper that we much need. So just to try and look at the global production market trends, you will observe that the global production, I don't know if you're able to see that move post like gas numbers. This is sorry. So this is a projection from 2007 to 2028, you can see that the production just go up. Sulfuric acid will continuously move up because of the demand in the application that I've already mentioned. And if you go by the market trend, it's the same situation. The prices of sulfuric acid will go up because the demand keeps on going. And if you go by country, you'll notice that China is the largest producer of this commodity. And it's not worth it, not wait that the sulfuric acid will continue moving up. And this is very much connected, by the way, to the GDP. If you mention any country that is doing very well right now in the world, whose GDP has grown, you discover that sulfuric acid is one of the chemicals that they are producing in large quantities. So a few things on the theory. Basically, that is the reaction that you get when you want to make your sulfuric acid. Basically, you start with the raw material, the sulfur, and this sulfur is in different forms. You can have it in pellets, you can have it in a gaseous form. So you react with oxygen to get your SO3 at that temperature. And then this is the SO3 or sulfur dioxide that you react with water so that you can come up with the sulfuric acid. Now, like I said, for us to produce this chemical in large quantities, we need a catalyst. And there have been various research that has been done so that we can improve on what kind of catalyst that is needed. Right now, the one that is being used commonly everywhere is the vanadium pentoxide. And that is a typical catalyst composition. Got the vanadium itself, the potassium, the sodium silicate, and of course, the sodium the silicate itself. So in this catalyst, the one which is very critical is the vanadium pentoxide, the P2O5, because that's the one that is speeding up the reaction. This process is based on the Shigara principle. Basically, what this principle tells us to say, if you have a shift in the equilibrium, the system will shift in a way to oppose the change. So this is what governs the process of sulfuric acid. And ensuring that, because our desire is that this process must go into the forward direction. So we need to set our parameters, which those are the critical parameters. You have the temperature, we've got the pressure, we've got the concentration, the reductants, as well as the catalyst. So we must ensure that these parameters push the process in the forward. So in this case, according to that principle, we want anything that happens, this system must shift into the forward direction so that we can produce the forward chemical that we need. So what happens? The first stage is, of course, to oxidize the sulfur dioxide into the sulfur dioxide. And we use a catalyst, as I said, and it's in a converter, which you call a converter beds. These red stuff they are saying, these are the beds that contain the catalyst. So the sulfur dioxide will enter at about 2.5 degrees Celsius temperature, and then as we agree, as the conversion is taking place, this reaction is very exothermic. So what will happen is that the temperature of the path will be going up. That's why it is moved from about 400 there and exit, hitting into the equilibrium curve. At that point, that is the maximum point you can have of conversion. Anything beyond, we are going to switch the reaction and it will go in the opposite reaction. So the red one, that's the first point of conversion. Then you put it in the blue line. The second line, you take it for further conversion. You put it further and then take it in the red until we reach the end of the conversion. In this graph that you're seeing about here, you are basically trying to convert your SO2 into SO3. So this basically is what I'm talking about. The incoming of the gas to the catalyst bed, and at that temperature, you heat it up, you cool it, you go to the next stage until you've got your maximum conversion. So after you have done your conversion from sulfur dioxide, the next thing is that you need to absorb that. Okay, you have to do the absorption, you take away that SO3 so that you can make your acid. So that is the equation. SO3 in a gas form reacts with the water and you produce the sulfuric acid. Now, I must state here that we don't actually just add water separately. We add what is sulfuric acid, because when I talk of sulfuric acid being 98%, the balance is water. It is that balance, the 2%, that comes in the equation to absorb the water, the SO3. The reason is that if I'm going to send a lot of water, that is very, very exothermic. What will happen is I will just end up forming acid mist, because so much heat will be generated. So for me to cushion, absorb that heat, we need to ensure that we send the heat water, which is acid and sulfuric acid. So this happens in a tower. So what you have on the left side, you have got the gas coming in from the bottom, and you've got acid being added from the top. So as they meet on a packed bed, you have now the water, the sulfuric acid being absorbed into the acid. So those are some of the few things that affect, of course, the production for the acid concentration itself, which is very important. Weak acid, the acid temperature, the tower design, the gas and liquid distribution, because that's very important in the driving force. For the SO3 to be absorbed, it needs to be driven, and that you consider the partial pressure that comes about with the gas and liquid distribution. And of course, the amount of SO3 that is in the streams. So after we have absorbed the SO3 into the sulfuric acid, basically what you do is you have increased the concentration. It's much in sulfuric acid, but depending on the requirement, we have to go for what? For dilution. Because some processes will require that our acid that we need maybe is 98% or 99%. So for us to attain that, we need to add water so that we can now end up with the required concentration that we need. And in doing so, we look at the plant water balance. Because what should happen is that whatever water that you are getting into the system and the sulfuric acid must come and meet and be able to produce a specified concentration. If your concentration is going down, you should just realize that the water balance is not good. In other words, your water is not coming at the right quantity that is needed. So, having spoken about the process and the theory, we will now begin to look at how many types of acid plants do we have. The classification of acid plants is dependent on the type of sulfur source that you have. In some cases, you need to have just sulfur pellets, which you need to burn in a furnace, and that is the sulfur burning type that we have. So you burn the sulfur in a furnace, your raw material is sulfur dioxide, then you can send it for the process that we just talked about. The other one is acid regeneration. This is where we've got spent acid, which you can burn in a furnace, and you end up with your SO2 that can also undergo through the same process. Then finally, we've got the metallurgical gas, Escobar. This is the commonest that we have in Zambia. We've got smelters in Zambia, and there's a regulation that you're not supposed to actually emit sulfur dioxide into the atmosphere. So this gas, after it has undergone smelting, we get that gas, pass it through cleaning, and we end up with SO2 that is needed. Then we can go for the same process to produce. So we've got three types of acid plants. Of course, this gas cleaning system applies the metallurgical gas where the gas is dirty, but as well as regeneration. But for the sulfur burning, the gas is very clean, so we don't need to go through this system of cleaning the gas by elimination, cooling, condensation, precipitation, and of course, some special processes to ensure that we can remove the impurities that are in the system. So this is basically just a flow sheet. What you can see there, the yellow, that is the sulfur, which is ending up in the furnace. After the furnace, it goes into the converter. From the converter, it goes for absorption, and finally, you take it for storage. Now, what are the available technologies? The most common available that we have now is the contact process. Now, this contact process has been verified in terms of how the arrangement, the configuration is. We've got the CSC-SA, which is single contact, single absorption. What this means is that when your gas enters your converter, it will go through all the stages of conversion, and at the end, you take it for absorption. That is one variation. The other one is the double contact, double absorption. So meaning that the gas gets contacted twice, it goes for absorption, goes for another contact, and then for the final absorption. In comparing the two, you discover that the DCDA is most efficient. Why? Because it's able to give sufficient time to bring the process to completion. No wonder if you look at the figure there, we've got 99.9% conversion, meaning very little gets into the atmosphere. And that allows us to ensure that what we are emitting is below the required. By the way, ZEMA has got a limit. We're supposed to just emit 4,300 kg of sulfur dioxide per day. So this has proved to be very efficient. We've got other technologies, the sulfur acid process, the peroxide scrubbing, the wet gas sulfuric acid, and the Peterson fatigue process. All these are the variable technologies that are there to ensure that we can use for production of sulfuric acid. Prominently in Zambia, we are just looking at the double contact, double absorption. We are just looking. What is the situation in Zambia? In Zambia, we've got 4 prominent smelters with acid plants. Transanshi with a design capacity of 4,400. KSM smelters got 2 with those 2 capacities, and then Mufrila and Chambishi smelter. Of course, there are other, these are all metallurgical based, by the way. Then we've got other that are based on it, except for 500. So that is sulfur burning, but the others are metallurgical. But we've got other smelters, I think like in Chingola, could not just get the capacity for that smelter. Now, what is the situation? The situation that we have in Zambia is that there has been an increase in importation of what? Sulfuric acid. This importation communicates to us that our production numbers, in as much as they are growing, the demand for sulfuric acid is going up. So for us to just be able to balance off, we need to import more sulfuric acid from Zambia. And also suffice to say, even these acid plants that we have, some of them are not producing, they've not lamped up. They're not able to produce to design. So this has created a gap for sulfuric acid in Zambia. And as can be seen, our price has even gone up to about $330 per ton. Previously, would get acid at about below 100. If you see any company that is selling by 175, 150, they've just gone into negotiations. But if you go on the market, you find acid fetching as much as 330. So this is indicative that we have a gap in terms of sulfuric acid. And if we've got a gap, we are going to have serious problems in terms of food, producing the products that we need. So currently, the Zambian government is very ambitious. They've announced that we need to produce 3 million metric tons of copper in the next 10 years, starting with 1 million metric copper this fiscal year. That becomes as a challenge to engineers, Because if we're going to produce that much, of course, we've got the hydrometallurgical route as well as pyro. So if you don't have acid, the hydrometallurgical route will be affected. Then, of course, currently we're saying the consumption of acid in the mining industry is about 5 kg per metric ton. It's going up. Why? Because our minerals, the percentages are going down. What that means that we have to use more of acid. So if you're going to have usage of more acid and then there's less, that also poses a challenge. So the way forward is to increase production to meet the demand for copper production. We have to increase sulfuric acid to meet the demand for copper production, as well as to make fertilizer, to make cement, the products that are able to make life better. And the good news is that the technologies that I've already highlighted are available. We are only using 2. So there is need that if we do a lot more research and everything, we can be able to implement the other technologies, because we are only using 2 out of the so many available. If we can implement all those that are there, we'll be able to match the demand that is there. And more importantly, we've got the engineers, the engineer professionals who are able to design, to construct, to commission, and they run these plants so that we can meet the demand that is placed on us. So in my conclusion, we are saying this is sulfuric acid is a very important chemical which can change our way of life. And like we looked at the numbers, there's so much connection between the level of acid production to the gross domestic product of a country. Technologies are there to ensure that we can have this sulfur dioxide, made into sulfuric acid for us to get the 3 million that we need for our nation. Next. A gentleman, James Cameron, said, if you set your goals ridiculously high and it's a failure, you will fail above everyone's success. So it's time that as engineers set our bar high, so that if we fail, we'll fail on the level of other people's success. Thank you very much.
Thank you very much, Mr. for that wonderful presentation. I would like to advise our colleagues to also set your bar high when asking your questions. You've heard that? So, yeah, if there are any questions, please, the gentleman is here to respond to them. You can set the bar high so that he gives us a response which is deserving. Okay, also are looking for questions. I would just like to emphasize something. I think from what is coming out in our presentations, we can be able to see that the idea is project management. It's one of the clear things that is coming on. And this is part and parcel of where project management happens, because stakeholders are being engaged, which are obviously us, who are part and parcel of the value chain. We've heard of sulfuric acid. Perhaps there's someone here who's looking for a business opportunity. This is the platform. And perhaps there's someone looking at proposing something that the institution could do to turn around what they've been doing. This is the solution. And for some of you that are sitting in important boards and your members, the idea was coming that you should be able to influence the decisions that are being made positively from these forums. This is where we're getting the ideas. So let's not stop this, and let's encourage one another to continue with this idea. I hope there are some questions, or the presentation was too clear or not clear. I don't know which is which. Our third presenter presenting virtually. Yes, you can go ahead.
Good evening. First, I'd like to say that the presentation was, I'd say it was very well. I think it was very technical. But then I think there's something that I got from the conclusion or the way forward, which talked about how the technology is available and the raw material is available. So my question arises on the raw material. I've seen that from your presentation, you picked 4 plants that are currently producing the sulfuric acid. So if we say the raw material is available, for example, is there a research that shows that we are going to produce the raw material enough as much as Kansashi is producing somewhere else? So are there places where we can put up those plants or the technology to produce the sulfuric acid that will be needed, of course, to what is needed for the copper production?
I think in the past 1 month or so, I've been receiving a lot of calls about people wanting to buy sulfur pellets. And when I did try to ask from a lot of people, discovered that actually Ndola has got a lot of sulfur. And not just in Ndola alone, in the Middle East. In the Middle East, there's a lot of production of petroleum. So they've got so much that they don't know where to take it. And the price actually of those items are going down. So when I talk of the materials being available, it's right here in Zambia, as well as in the Middle East. So all that is needed is to put up the plant and draw that material so that we can use. In terms of the metallurgical, we need setup of smelters, which is not a small thing to do. It's quite a massive project. But for these small technologies I was talking about and the sulfur penning, these are something that needs to be put up. So the raw materials is very much available for us production. I hope I've answered. Thank you.
Yes.
I would like to thank the 2 presenters. It's a wonderful presentation. I think my question is, currently, when you talk about copper production, we are standing at 860,000. And then there's a plan for us to, improve on production to the 3 million per year in the next 2 years. Now, I wanted to understand. So at the moment, with what we are producing for those 4 smelters, how much are we producing in terms of sulfuric acid? And then if the production is increased from 860,000 to 3 million, how much will the sulfuric acid increase to? I think those could have, maybe those statistics could have helped us to understand, to say the increase in copper production will be able to increase the sulfuric acid production. If there is a challenge with the companies, why they are not producing as per target, how can the companies be helped so that we have enough with what we already have? Of course, you talked about producing from sulfur and others. I think those are investments. But with what we already have, is there a way that sulfuric acid can still be improved? I think that's my question. Thank you.
Data shows that for every ton of copper, you produce 2 tons of sulfuric acid. I think in the range of 1.8 to 2. So if you are to take the current copper production, just multiply that by 2. That gives you how much sulfuric that we are getting. As in how those plants are producing currently, I think if my memory serves me very well, the only company that is producing to its maximum is Kansashi. these other plants are having difficulties to produce. One of the issues being that over time, the mineralogy has been changing because of where they're mining from. So that has impacted, they're not able to ramp up. And then of course, other companies, of course, challenges with basically deterioration of the acid plants that are there right now. So hence the need that if we have other companies putting up, that is going to adapt to the loss, that to adapt to already what we are producing. Because if we just talk of trying to improve on the current numbers, it might be a bit difficult, especially if the issue has to do with mineralogy that has affected the numbers. Now, putting up a new plant would be much a quicker way to actually bridge up the gap. Thank you.
Any other question? Yes, please.
Good evening, yes. I was tempted to remain mute on the grounds that but this presentation has surprised me. What has excited me is that he's brought out the aspect of an opportunity. He's brought out a gap that wasn't visible in terms of market or availability for the sulfuric acid. It would be interesting to hear from the presenter the market beyond Zambia. And what you brought out is the deficiency in Zambia. How is it in the region? Let's talk about, for a start, let's talk about the southern region. How is the deficiencies, or is there enough? South Africa, for instance, do they have plenty which can easily flow into Zambia, such that our efforts to ramp up may be defeated by inflow from South Africa? How is the southern region in terms of availability and basically market products, which is so important? Because we are talking about investing to get to those high levels of production. Even in the existing mines, for us to get to the 3 million tons of copper per annum, there's need for money. But are we just going to invest with Zambia in mind, or we are looking at the product? Thank you.
That was more kind of question. Yeah, but in the southern region, we are affected. Of course, I don't have the numbers on my fingers, but one country which is so much in need and which is actually become a big market for sulfuric acid is Congo. Congo so much deals with, has got a larger deposits of copper oxide, and that has triggered the need for sulfuric acid. And it's one which is drawing quite a lot, getting acid as far as South Africa. South Africa, if you had to make a comparison with Zambia, I think in my presentation I must have indicated at some point that Zambia did import in 2019 about in terms of monetary terms about $1 million of worth of sulfuric acid from South Africa. That just came into Zambia. So that is an indication that no, the way it is that even when your car, the company, you don't have sufficient, but when the market pops up, you can be able to even to sell the little that you have just to have some money. So in the region, the country which is most affected in terms of acid is Congo. Yeah, I think that's my answer to this.
There are no questions. I think answered very well. Perhaps maybe for your information, we might be looking at copper production, but there are also other minerals that are being produced or processed in this country. Production rather is somewhat of, I think, a conundrum, because the minerals are here, but we can say processed. I think manganese is something that has gained popularity. For your information, if you didn't know. If you look at Central Province particularly, there's been a lot of manganese activities happening there. So the importance of sulfuric acid comes into aspect. We can see how much popularity and demand there is for a market for sulfuric acid in our country. I think at this juncture, looking at time, I wouldn't want to keep us here. I think it has been a very productive public forum discussion. I would just like to find out if there were no questions that are lingering for the first presentation. If not, without further ado, may I call upon Kitwe Branch Chairperson, Engineer Christine Banda, to give us a vote of thanks or closing remarks.
Thank you, Engineer Langamu. Good evening, ladies and gentlemen. As we wind up our program today, I just want to thank you all for having attended with us, those who came in person and those who joined us online. It has already been done, but I'd also like to acknowledge the presence of our Vice President, Engineer Milubi, for joining us. We appreciate your presence. Talk about a few things regarding our Kitwe branch and forum programs that we have for you. As you've all seen today, attendance levels seem to be very poor, both here at AMO and also online. Personally, I'd like to see a situation where, as the executive, the branch executive, we are overwhelmed to fulfill your needs. As it is, you are not challenging us. We want you to challenge us. Come up with so many presentations that we don't know what to do with them. I'd like to thank the presenters for today. We did put out a call for presentations. We mostly used WhatsApp, and I believe the gentlemen here, they responded to our call for presentations. We'll continue doing that, so I'd like to ask all our members, technicians, technologists, engineers, any engineering professionals, and also non-engineering professionals who have topics that are of interest to the engineering fraternity to approach us so that we create a forum for you to present your topics, your ideas. Would like to have as many people be involved to keep talking. I mean, I'm sure we're all motivated. I'm sure after this, somebody is going to start talking about putting up a sulfuric acid plant. Imagine if we have more presentations, we have more people who are motivated and challenged to come up with solutions to the problems that we're facing. So as I mentioned, we had put up a request on WhatsApp. We're going to do it again. So if there are people in the audience, whether here or online, who have presentations that they would like to make, you're most welcome. Presentations are welcome on anything. Today we had presentations on climate change, sulfuric acid production. Next time, I'd like to see a presentation on entrepreneurship and finance and health and safety, any topic that has an impact on our engineering profession. And just to close, I'd like to mention that for this year, 2022, as a branch, we would like to organize a marathon. I am hoping all professionals will participate. We are targeting May. So in May, we'll start preparations very soon. I'm hoping all engineering professionals will come on board to support us. And also, we would like to organize a tour of a gemstone mine. So I think these are the two main things that we'd like to do under the branch, maybe the first 2 quarters of the year. So I'd like input from the engineering body, Kitwe branch. Like I said, I would like a situation where you are pressuring us because you want to see engineering profession having discussions, having meetings, networking, and all that. In conclusion, thank you for joining us today. This is the first forum under Kitwe branch for the year 2022. We hope to have another one early in the second quarter, and so we'll be looking for more presenters. Thank you to the presenters who joined us today, and we look forward to seeing you at the next forum. Thank you. Thank you.
Thank you very much. At this juncture, I would just like to call upon Vice President Engineer Melupi to address us and just a few words.